Hey everybody, I know people have been asking about the different forms of linear equations, so I wanted to put this little project together and just go over the materials that you're going to need for starters. So first thing you're going to need, of course, is some kind of a notebook, preferably one that is cloth bound or sewn bound with stitches. If you've never done one of these before, it's a good idea to save a few pages at the beginning just for your index. And this is a good idea for all notebooks, actually. So we'll look at that. So I've done other projects in here. So I always number my pages so they're easy to find. So we're going to need one of these. It can be this kind. It can be, I've got plastic covered ones. Those are cool too. And you're going to need the 3 pages that I sent you printed out. So there's the 3 pages. A pair of scissors. And it rolled off. I don't know where it went to. But you're also going to need a glue stick. There it is. A glue stick and actually a stapler. So those are the supplies you're going to need. So gather those together, put this on pause, and when you come back, I'll talk to you all about the next step. Okay, here's our first next step, and this is going to be a flippable that you're going to glue into your notebook, all about slope. So what we need to do is we need to cut out all the rectangles. So there should be 1, 2, 3, 4 rectangles, and then we're going to stack them on top of each other so that the biggest one's on the bottom, the smallest one's on the top. So I'm going to pause the video while I go ahead and do that. I'm actually going to do that with the other 2 pages as well, but I'm going to make sure that I keep my pieces together for each page. So we'll see you in a few minutes. So there we go. We have everything under control. I'm just checking my mic here. We're doing good. Okay. So I cut up actually all 3 pages, and it took me about 10 minutes, and I was trying to be as precise as I could. So it doesn't really take that long. All 3 of these are going to kind of have the same idea. Okay, so I'm just going to work on this smaller stack right now. And basically all I need to do is I need to put them in order in size, from biggest to smallest. And it's usually going to be the example that's the biggest one. So I just neaten that up, pull out my little stapler, and there, I've got one. I'm going to put a couple staples in it because we're going to be folding these a lot. There we go. And then we're going to kind of follow the same process for the other ones. So, okay, this one is the example, so that's probably the biggest. Let's see, this one is the smallest. Good, that's what I'm used to seeing, right? Y equals mx plus b. So we'll tap those, make them all nice and pretty, or whatever, and staple them. You can use another method. I suppose you could try and tape them or glue them. I wouldn't really recommend the glue, because since we are going to be folding these a lot, and writing in them as well. So there we have that form, and then the last one with the big long pieces. So here's the biggest. Y's are usually on the other side. Ooh, teeny tiny. Can't forget that one. Okay, so this is me even knowing what the formula is supposed to look like. Phew, there we go. Now to pick them up. Again, my clumsy fingers. There we go. Oops. Okay, so I'm not a real pro with the stapler, as you can see. But that's okay. My recommendation though is to make sure that you staple from the top so that the sharp points are at the back. And I was actually thinking as I was cutting these out, I was like, I should have done these on different color paper. That would have been so cool. And all I could find was pastel, and I had already cut up 2 of the pages. I'm like, no, 2 white pages and 1 pastel. Not exciting. So here we have the point slope formula. So the next step is, and you can do these on whatever color paper you want. And if you don't have colored paper and you want to color these in, then go for it. So what we're going to do, it's a little bit longer than I expected. We might have to go a little bit sideways, but it's going to be fun. We'll see. First thing I'm going to do is in my notebook here, I'm going to write on page, let's see, I'm going to call it pages 6 and 7 because I might need 2 pages. So I'm going to say, number this one page 6, number this one page 7. And that's just because I'm trying to stay organized. And then I write down here pages 6 through 7. Make it so you guys can see it. 6 through 7. This is going to be forms of linear equations. You'll know where to find it. So this is where the glue stick is coming in. Turn to that page 6. Here we go. And I'm actually going to turn this way. I'm going to turn it this way here. Mostly because I want this guy to fit. So that's kind of what's doing it for me. So I think I would suggest putting up the slope formula first because so many things depend on it. So I'm going to take my glue stick and glue stick it on. We only need to put glue on the one side. So, it seems to curl up when you do that. Excellent. So I'm going to glue the rest of these on and wait for them to dry, and then I will come back and we'll do a little bit of practicing. Okay, so mine's pretty well glued down. I just glued it down here. I left some room at the bottom because there is another form that's not included in this packet, but we can certainly talk about it. So there's, of course, some kind of explanation that needs to go along with this. This is going to be talking about the slope formula, and when we flip this over, we see we're going to be talking about this y2 over x2, this part of it, and this is the xy value from I'm going to call it group 1. And that's referring to, group 2. And that's referring to a particular ordered pair. Okay, so it's referring to this kind of thing. x up, just an x and a y. So we have 2 points. So so this is the coordinates from one of the points, and these are going to be the coordinates from the other point. So this is the x and y from group 1. That's just so we know what it is. Okay. So let's take a look at an example. It says find the slope between 3, 7 and 5, 11. So we need to call one of these group 1 and one of these group 2. Since this one came first, I'll call that group 1. And since this one came second, I'll call that group 2. And if we remember the formula for slope is m equals y2, so that's going to be the 11. Whoops, not an h, it's going to be an 11. y2 minus y1 divided by x2 minus x1. We simplify that, so we simplify the numerator. 11 minus 7 is 4. Denominator, 5 minus 3 is 2. Simplify that, it's going to be 2 over 1, or 2. So the slope of the line between 3, 7 and 5, 11 is 2. Now, I have another way that I'm going to just kind of show you a little bit over here. It's a little bit easier for me because that way I don't have to remember which one is group 1 and which one is group 2. I like to just take the two the 2 points and stack them on top of each other. Any order. As a matter of fact, I will this time put the smaller numbers on the top. 3, 7 and 5, 11. Okay, and then I'm going to subtract them. So I've got 7 minus 11 is going to give me negative 4. And then 3 minus 5 is going to give me negative 2. So this is the difference between the y values. This is the difference between the x values. So our slope is negative 4 over negative 2, which can be simplified to 2 over 1, which is 2. So our slope is the same. And the only thing we have to remember is that these two differences, we just need to flip them like that. So that's a little bit of a shortcut for slope, but it really does this. Okay. So the next one that is one of our favorite forms of linear equation is the slope-intercept form. And that's what the next one is. The famous y equals mx plus b. You know how it goes, right? So let's put some important stuff on here. So let's look at the m. The m is the same m as here. So this is the same as the slope. Okay? So yep, exactly the same slope over here. Okay? So now our x here, this is going to be our independent variable. And x is almost always our independent variable. Okay, so we plug in any x, g, plug in any x value to find a y value. Okay, that's what that x means. It can be any x at all. Alright, flip this one over. And now we're going to talk about the b. So this b is the y-intercept. And this is where the graph where your graph touches the y-axis. Okay? So let's take a look at an example. Okay? Well, let's take a look at maybe y equals 2x minus 3. So this is our y-intercept. So let's start there, which is -3, right there. And then the slope tells me to go up 2 and to the right 1. Up 2 to the right 1. Up 2 to the right 1. So this is what that is. Up 2, right 1. To get from dot to dot. This is our y-intercept. Intercept. Which happens to be when x equals 0. Because that's the value of the y-intercept. That's where x, or the y-axis, that's where x equals 0. So, cool. Awesome. Okay, this next one, the long skinny one, this is called the point slope formula. And it's called this because you use it when you know one point and the slope. That's why it's called the point slope. Okay? So if we start here, this is just going to stay y whenever we write these. Okay, this is just going to stay y because that's what we're looking for. But this one here is the y from any known point. Okay. This m, that's the same m from up here. Slope hasn't changed. Slope. Oh, Yanto, you hear my puppies, I'm sorry. Okay. This x, this is always going to stay x. Because that's our independent variable. Independent variable. And then this one is the x from the known point. Like the y1 was from the y point. So in our example, it says find the equation of the line with a slope of -4 that passes through 9, 3. So our slope, there's our slope. This is our y1, this is our x1. So it goes y minus 9. The thing to remember is the minus. That's the hardest part to remember. Equals the slope, -4 times x minus x1, 3. There we go. There's our point slope formula. So I hope this was helpful for you. I did want to add one more piece to this, one that we didn't talk about much, or that we don't have flippable, but it was the standard form. It's one we talked about in class. This is the standard form. It says that this is ax plus by equals some number. You can't see that? Okay. Not a super helpful form. It's good for finding the intercept, so if you have to graph it, because the intercepts can be really important. But if we wanted to make this into maybe slope-intercept, means we'd have to solve for y. So in order to solve for y, we need to subtract ax from both sides. And we end up with by. And a, b, and c, they're just numbers. They could be the same numbers, they could be different numbers, they could be positive numbers, they could be a mix of positive and negative, just any kind of numbers. So that's c minus ax. And now I have to divide this by b, and when I divide this side by b, I have to divide everything on this side by b. So here's my division by b. I end up with y equals c over b minus a over bx, which is a nice way of finding the slope real fast if you have a standard form. So it's a real nice way that the slope from standard form is negative a over b. It's not something that anybody teaches. It's just a pattern that I've noticed, and I thought you might benefit from the shortcut. So I'm going to finish this up, and I hope you enjoyed this, and I wish I had just made the paper more exciting. So I hope you have a great day, and I hope it helped.